Alright, welcome back. We are continuing with a linear combination of two random variables. So do remember the formula from previously. For the expected value, it's the expression where the coefficient is outside the expected value of each variable and as a sum. That is pretty straightforward. For the variance of the sum of two variables, you will look at the scale factor for each variable and square it as a coefficient. So again, the fact that you square it allows you to keep it positive. So as the variance is always positive, that will work well. You can then square root that amount to find the standard deviation. Alright, let's look at one example. Again, read the text, pause the video, read the text. Remember to use your cube technique to just isolate the different type of informations, and we'll get to it. Alright, let's continue with this. So you have two random variables. You have your x and y, which are x is the time taken to prepare, which you get the relevant expected value and standard deviation, and you have the same with the second one, which is the time taken to paint the house, with an expected value here and a standard deviation. Probably the next step is to determine what's the combination of it. So with the combination, it's the total time taken, therefore it's just the x plus y, and then we can determine the expected value, which is a sum. The variance, the coefficient in front is a 1 respectively. Don't forget here, we know the standard deviation here, so you need to square those to get the variance again. We calculate the new variance of that new variable, and then we square it and get the new standard deviation. Alright, now we want to find that probability that is more than 35 hours. You write the probability as it is. We'll see that a bit in methods. The process of standardizing is you take that amount, you minus the expected value, and you divide by the standard deviation, and I'll give you that z in equation, which is the standardized variable. From that, you use a function on the CAS calculator to determine its value. Probably because it's a 1, there's a way to do it by hand, but anyway, it's a CAS calculator function. Alright, and oops, I think I was in the way, so just in case you needed to see the rest. Okay, probably I need to go back to the previous slide. If you see, no, that was fine. Okay, so this is it, pretty short, and I'll see you in the next video.